Assalamualaikum and hi everyone. So this video will explain about the subtopic 2.2, which is statically determinate and statically indeterminate, right? So this example is from the notes. Example number 6, we will discuss that relate with the statically determinate. Okay. So the question is the rigid bar BDE here is supported by two links AB and CD. So link AB is made of aluminium with the Young modulus of 70 gigapascal and has a cross-sectional area 500 millimeter squared. Link CD is made of steel with the Young modulus of 200 gigapascal and has a cross-sectional area of 600 millimeter squared. Okay, so area for link AB and CD is given. For the 30 kilonewton for shown, determine the deflection of B, D and E. Okay, so the force here, the external force here is given with 30 kilonewton. So by logic, we can see that this bar BDE are going to have a moment, right? Going to rotate this way. See, this is the load. Okay, so the bar might be come like this. Due to the force. Okay, so now whenever the bar is moving downward, it rotate like this, we are going to look and we are going to calculate the deflection that will happen to link AB and link CD, right? Okay, so first thing first, what you have to do is to come out with the take out the link AB, and then we have link so this one for AB, link CD. As well as the link ataupun bar BDE, the FBD for bar BDE. Okay, so as you can see here, we have PAB upward, PCD upward, and 30 kilonewton of course downward lah. This one relate with static, since we take out the two force member, kita kena dia punya direction should be opposite lah, right? Next, we are going to make a table like this in order to substitute into question later on, right? It is easier for us to come up with the table so that we are not going to have a mistake. So we have two deflection here that we are going to calculate, which is delta AB and delta CD. And then for the length, it is stated in the question 0.3 meter and 0.4 meter. Area also given, which is 500 times 10 to the power of negative 6 meter squared and 600 times 10 to the power of negative 6 meter squared, and E also given. For link AB is made of aluminium 70 gigapascal and link CD is made of steel with Young modulus 200 gigapascal. So now we have to find the value of P. Based on the FBD for BDE here, we apply the static equilibrium equation, which is summation of moment at point B equal to 0. So we can get PCD equal to 90 kilonewton. Next, summation of Fy equal to 0. Then we can get PAB equal to negative 60 kilonewton. Right, then we put it in the table here, 90 kilonewton, negative 60 kilonewton and 90 kilonewton. And please take note that the negative sign at PAB is show that the PAB is in compression. So we need to find the deflection of of B. So deflection of B equal to delta AB. Then we substitute into the equation delta AB equal to PL over AE and put all the value, then we can get the delta AB. So we can get the delta AB equal to negative 5.14 times 10 to the power of negative 4 meter equal to negative 0.154 millimeters. Okay, so this shows that the link AB is in contraction due to the negative value. Next, we have delta CD. Substitute all the value into the formula and we can get the delta CD. So delta CD equal to 0.3 millimeters and it is in expansion. Next, we are going to find the deflection of E, which is equal to delta E. But for deflection of E, we cannot use the formula delta equal to PL over E because we have no axial load here. No axial load at BDE. Okay, so we have to use trigonometry method. By using the trigonometry method, we take our bar BDE. So based on the deflection that we have calculated before, at point B, we have a contraction, right? So this is point B, point D and point E. So contraction, the link AB will move upward, and then for link CD, it is in expansion, as well as the point at E, it is pointing downward. So we have three lines here and we need to join the line so that we can calculate the trigonometry method. So label here is delta AB, delta CD and delta E. So we already have delta AB and delta CD. We are going to find delta E. So the distance here to here is 0.2 and 0.4. So we assume the distance here to here is x and the distance here is 0.2 minus x, and then here from here to here is 0.4 plus x. Okay, so make sure you clearly can see the distance, right? So we apply the trigonometry method. We assume that we have a theta here, same angle. So we have a delta AB over 0.2 minus x equal to delta CD over x, and is also equal to delta E over 0.4 plus x. Okay, when we have this equation, we can solve for x. Okay, substitute the value of delta AB and CD here. then we can find the value of x. So x equal to 0.0737 meter. Then we need to substitute x into this equation so that we can find the value of delta E. So then we can get the delta E equal to 1.928 millimeters. That's it for this kind of question. So I think you can try apply this method for tutorial question, and if anything, just let me know. Thank you. Assalamualaikum.